Welcome. This is a quick narrated tour of HiDream-O1, a new open-source image generation model released in May 2026. In about 4 minutes, you will see what it can do, where it shines, and where it falls short. Let us start with the basics. What HiDream-O1 actually is, and why it is different from other image generation models you may have used. HiDream-O1 is unusual because it handles 5 different tasks from a single 8 billion parameter architecture. First, text-to-image. Describe a scene in words and get a photograph back. Second, image editing. Change one thing in an existing photo while keeping everything else the same. Third, subject-driven personalization. Place a known person into a brand new scene, preserving their identity. Fourth, bounding box layout conditioning for precise region control. And fifth, skeleton conditioning, where a pose reference drives the body posture of the generated subject. Most diffusion models specialize in 1 or 2 of these. HiDream does all 5 natively. The open model ships in 2 flavors. Full is the heavyweight, 50 diffusion steps, classifier-free guidance turned on, the highest quality output. Each image takes about 3 minutes on an RTX 4090. Dev is a distilled variant, only 28 steps, no guidance, and roughly twice as fast, about 17 seconds per image. Both versions ship in BF16 precision for the upstream pipeline. There is also an FP8 quantization available, but it is built specifically for Comfy UI integration and will not work with the standard inference code. Now, let us look at 7 real examples, covering all 5 generation modes, plus 2 architecture diagrams to show where the model really shines and where it stumbles. First example, pure text-to-image. We give the model a single prompt describing an editorial sunrise scene at a writing desk with no input image at all. We use the fast dev variant, 28 steps, no guidance, at a 3:2 aspect ratio. And here is the result, rendered in about 17 seconds. Notice the directional window light coming in from camera left, real steam curling above the mug. The leather binding on the notebook has plausible texture. The brass details on the lamp render cleanly. And critically, the handwritten cursive in the open notebook stays as actual flowing cursive, not garbled glyphs, which is the failure mode you see with most image models. This is HiDream at its strongest, photographic compositions with rich detail. Second example, instruction-based editing. We give the model a portrait photograph and a simple instruction. Add a pointed dark purple wizard hat with golden stars and a crescent moon. We keep the original aspect ratio so the photograph is not cropped. The full variant runs at 50 steps with guidance scale 5. The result preserves the source image almost perfectly. The face, expression, shirt fabric, and gray backdrop are pixel comparable to the input. Only the hat is new, and it integrates with the lighting naturally. The gold stars and the crescent moon both render cleanly because the prompt explicitly described them. For targeted edits like remove the earphones or change the shirt color, this is the workhorse mode. Third example, subject-driven personalization. We give the model 2 reference images of the same person, a full-body shot and a tight face crop, and ask for a rugged outdoor portrait in a brand new scene. 2 reference images outperform 1, because the model was trained for multi-reference inputs. We also lower the guidance scale from 5 to 3.5 to reduce the so-called AI look on skin tones. Identity locks beautifully. The man in the wooden gate scene is recognizably the same person from the references. Bald, salt and pepper goatee, same bone structure. The olive jacket, the moody overcast sky, the dry windswept grass all match the prompt. But there is a key lesson here. An earlier version of this prompt described short dark hair and a dark beard, while the reference shows a bald man with a salt and pepper goatee. The model followed the prompt over the reference, and identity drifted away. The rule: in subject-driven mode, never describe physical features your reference does not have. Fourth example: multi-subject composition. We ask the model to put two subjects into a single frame, the same person, and a pit bull dog with specific markings. Diffusion models typically struggle with multi-subject scenes. Let us see how this one handles it. This is the strongest identity preservation in the entire set. Fully bald with the mature salt and pepper beard matching the reference, plus the quilted olive jacket, cargo pants, and high-top sneakers from the prompt. The pit bull has the cropped ears and the studded leather collar. Two fine details the prompt called out specifically. Multi-subject composition handled cleanly on the open 8 billion parameter model. Fifth example: restoring an old photograph. The input is a black and white studio portrait from the early 20th century. The prompt is deliberately minimal. Restore the photo, remove scratches, make it look like a modern photo, keep the face the same. Just one short sentence. The result preserves the tarbouche, the felt fez hat, the full white mustache, the elderly features, the chair brocade, the suit, and the seated posture. All from the original. The improvements are pure quality: color, dust removal, dynamic range. Here is the counterintuitive lesson. An earlier version of this same demo used a long, elaborate prompt specifying the suit color, the hat material, the lighting direction. The result drifted to a much younger man in a fedora. The fix was to strip the prompt back to one short sentence. Long prompts invite the model to re-render. Short prompts anchor it to restore. Sixth example: architecture diagrams. HiDream is surprisingly capable at cloud and software architecture diagrams when you respect its density limits. We ask for an isometric data center with 4 labeled server racks. All 4 rack labels: Web tier, API tier, DB primary, DB replica, render correctly. The 3D isometric racks are stylized but accurate. The platform with stepped connectivity arrows suggests a real architecture asset. Isometric works well because the visual complexity carries the diagram. There is less reliance on dense typography. And finally, the failure case. We ask the model for a UML sequence diagram, 4 vertical lifelines and 5 horizontal method call arrows between them. This shows where the model breaks down. The structural template works. 4 vertical lifeline boxes at the top, labeled correctly, dashed vertical lines descending. But the labeled horizontal arrows between lifelines, the actual content of a sequence diagram, did not render at all. Sequence diagrams are HiDream's weakest diagram type. For real, sequence diagrams use Plant UML or Mermaid. Reserve HiDream for the title card. Thanks for watching. Every prompt, every configuration setting, and every lesson learned along the way is documented in the full article on my homepage. Scan the QR code or visit omkamal.github.io/articles. I am Omar Hosni.